The nuclear fuel cycle is an industrial process to produce electricity from uranium in nuclear power reactors. The cycle starts with the mining of uranium and ends with the disposal of spent fuel and other radioactive waste. As the first step of the nuclear fuel cycle, uranium recovery focuses on mining natural uranium ore from the Earth. The mined uranium ore is crushed and chemically treated to separate the uranium, which is called milling. This process leaves us with yellow cake, the powder form of uranium oxide. In general, conversion is a process in which the uranium is converted to a form suitable for enrichment. Natural uranium only contains 0.71% of uranium-235, the isotope that maintains a nuclear reactor's chain reaction. To increase the concentration of uranium-235, the yellow cake must be converted into uranium hexafluoride gas. As most nuclear reactors require fuel with a uranium-235 concentration of 3 to 5%, the proportion of the uranium-235 isotope must be increased. This process is known as enrichment. This is done by introducing the UF6 gas into fast-spinning cylinders known as centrifuges, where heavier isotopes are pushed out to the cylinder walls. Enriched UF6 is converted to uranium dioxide powder and formed into small, solid cylindrical pellets. These are packed in long metal tubes which are grouped in fuel assemblies. Controlled fission, or splitting of U-235 atoms, generates heat. The heat produces steam at extremely high temperatures and pressure. The steam then spins a turbine to generate electricity. Nuclear fuel is typically used in the reactor for 3 to 5 years. After removal, it is stored underwater, which provides both cooling and radiation shielding. Later, it can also be stored dry in shielded buildings or casks. Material in spent fuel can also be recycled to produce more energy. Some countries chemically reprocess spent fuel to separate the usable material from unusable waste. For this, plutonium and natural uranium are mixed to make a new type of fuel and can be reused in existing reactors or in fast neutron reactors. Spent nuclear fuel or high-level waste can be safely disposed of deep underground in stable rock formations. Waste is packed in long-lasting containers and buried deep in the geological formations chosen for their favourable stability and geochemistry. The first such disposable facility is expected to be operational in the near future. The IAEA supports its member states in using nuclear technologies in a safe, secure and sustainable manner.